Welcome to the Carousel Data Center Innovation Series, where we take a close look at the tech, trends, and issues shaping the future of data centers in the public sector. I'm your host, Carousel Consulting CTO Scott Robon. We have the great opportunity today to speak with Dr. Darren Pulsipher, Chief Solutions Architect of Intel. Darren has some great insight into dealing with cost efficiency regarding AI and many other related topics that we're going to get into today. Well, Darren, welcome. Thanks for being with us. As we get started, could you give our listeners a brief intro, a little bit of your history in the data center space and the roles that you play in the industry?
Yeah. Hey, thanks, Scott, for having me on the show. It's a privilege. My background is very sordid background, right? I'm a software engineer by trade. I went to MBA school after being in the trade for about 4 years because I realized no one can manage software engineers. So in MBA school, I learned that no one can manage software engineers. They're an odd group of people, right? Was hard to control, but I still went that route. I ended up being a CIO of a one product juice company, $1 billion juice company, and cut my chops in executive ranks there. And then I
Okay.
eventually ended up at Intel, where I ran a couple groups inside Intel, and now I have the greatest job in the world, working with Intel's customers to help them with their digital transformation. So I'm loving where I ended up in my career.
And just to give light to this, you also have lots of conversations with other industry people through some other fora. Can you just speak to that real briefly?
Yeah. I'm the host of a podcast called Embracing Digital Transformation. Just recently hit number one on the technology category. So I'm pretty excited about that. I shouldn't say the word proud. I'm more in shock that has happened. But I've had the great opportunity of talking to industry leaders from all over the world and some not industry leaders from all over the world, some startups that are just
Sure.
getting their teeth cut. So it's been a lot of fun.
I'm with you. I am nowhere close to your rankings in podcastdom, but I also do some focus on IT operations outside of this series, and I just really enjoy the ability to talk with many other people trying many different things, like executive leaders of large companies and the small startups that are really trying to don't have the technical debt and can have a little more agility
They
in
can
making a
move.
difference.
Yeah, they
That's
can
right.
move really quick. So it's fun talking to them because that energy, it reminds me of some startups I did in the 90s when I talked to these AI startups. I'm like, "Oh, I kind of want to be part of that, but I don't miss not sleeping for days on end." So,
Right, right. Well, so that's a perfect entree to the topic du jour. You mentioned being involved in the AI in the 90s. Of course, this has been around as an academic activity since the 50s, if not the
oh
60s.
yeah.
And a lot's changed in the last 3 years. There's a lot of hype around generative AI, and there's a lot of reality. Give us your initial take on, how has the AI boom shifted priorities in industry, common misconceptions that organizations have? Let's just start there.
Well, I think we need to go all the way back into the 80s to understand this a little bit. Um, the November 20th of 2022, everyone should know that day, is
Right.
when ChatGPT launched. But AI has been around a long time. Just like when the iPhone came out in 2007 or the mouse came out in the 90s, or early 90s. That technology had been around for a long
Sure.
time, right? Other people invented this stuff. But what makes a technology, blossom like that was accessibility and ease of use. Something
Mhm.
Steve Jobs knew a lot about, was, hey, if I make it easy to use, people will use it. And um, Sam Altman took the same approach to ChatGPT. He made it highly accessible, and it did something really cool. It responded back, right? I didn't need a
Right.
PhD to do the work, which before all the AI stuff says, well, you got your data scientists, they will analyze the data, they will clean the data, then we'll put it into the AI, we'll analyze the results and all coming back. And that's very valuable work. But Sam Altman made it so anyone could start working with an AI, and then that unleashed all this money. And where money
Right.
flows, innovation happens. So I think that's what
Yep.
we saw with ChatGPT was accessibility, and it changed the world overnight. It was an amazing moment.
And that's the face for most of us, right? The let's call it average consumer, typical consumer. But there's also API access for developers and other organizations that's hidden to most of us. Probably don't can't go too deep on that today, but there's much we're seeing the tip of the iceberg. There's so much more happening,
Oh,
beneath the surface of the water.
so much
Yeah.
more going on, and I you may or may not like OpenAI and what they did. There's some people, especially in the AI community, that have been around for decades, are like, that's not fair, right? He did something easy. I've been working on this hard problem over here, like object detection and video detection type things. Yeah, well, you know what? Too bad. You know?
Yeah.
Um, he found a way of making it highly accessible, and it unleashed a bunch of money for a lot of really great research in AI. So that's all good.
Yep. There's a parallel to, the first web browsers, right? Putting a graphic
Yes.
user interface on the front end of the internet. And soon after, my mom got an email address, right? So,
Yep.
that hockey stick happens. And we've certainly, since late 2022, we're seeing that up and to the right, incredibly sharply. Now, one of the big topics that keeps coming up here is accessibility to energy. Um, more, I think, is what we need, or at least that's what's said. Talk about your perspective on why is this becoming a pressing issue, and
Oh,
how are we going to address sustainability goals, through that power hunger.
well, I mean, a great example is ChatGPT 5, which just came out recently. Its power envelope is 10x that of 4.0. 10x. As massive,
Right.
right? We can't keep growing like that. We don't have enough energy to do that. The great news on this is not everyone that wants to use AI needs Chat GPT 5 or Anthropic's Claude, or we're seeing the emergence of small language models running on lower power devices,
Hmm.
like an AI PC, right? Specifically like a neuromorphic processing unit. Now, instead of talking kilowatts to get a response, we're talking watts, a
Right.
thousand times less, which is incredible, right? So we're seeing the emergence of new chips out there that will drive power down. And also, we're also seeing the use of small language models to get work done instead of really cool chats and doing better emails. We're seeing small language models being used to process a lot of data that is unstructured data, but I want it to be structured. So it's a very well known type of problem. I can use normal computing to do that stuff that I already have at a fraction, a tenth, a hundredth of the power envelope that we're seeing with these big, huge models out there.
Could you bring us some concrete examples of a small language model, and maybe for the layperson listening, what are the differences in training a small language model versus these foundational large language models?
Oh, I'm glad you brought that up, Scott. So no one should be training their own models anymore. It, there are so many models out there that have already been trained, especially small language. The difference between a small language model and a large language model is the number of parameters that it has. The number of parameters that a model has increases its ability to predict the next tokens or the next words that are going to be said and to be more creative and things like that. Most of the big boys out there, they actually don't have trillion parameter models. They claim they do, but they actually have several dozen smaller models that are interacting with each other. That's how
Hmm.
they all work. Well, a lot of the work that I need to do, I don't need all that creativity. I just need maybe to process for financial information. Maybe I need to process organizations' 10Ks or 10Qs that are filed with
Sure.
the SEC. Those are unstructured data. They're in PDFs typically.
Right.
And maybe I just want to analyze revenue streams out of a bunch of 10Ks out of the semiconductor industry that Intel's in, for example. And I want to analyze that. Well, I can use a small language model that has maybe a billion parameters to it because it does really good at interpreting language and context. And I don't need all
Mhm.
the creative stuff. And I can constrain it to say, I'm only looking for this one specific thing. And that kind of model can run on a laptop, right? Very small power, but it can give me all of what I need done. So instead of it being creative, in fact, I don't want it to make up numbers, right? If
Right.
I want it to be
Correct.
very
Yeah.
constrained.
Sure.
So if I use these models for very specific types of use cases, like getting financial data out of unstructured, 10K, 10Q data, these small language models are perfect for that, right? And we're actually doing work with the US Census Bureau to do exactly that, to help
Very cool.
their analysts look at unstructured and survey data and even structured data and to pull information out quicker so the analysts can get to results much faster.
That's and for perspective, we do have to understand what unstructured means from the data processing perspective. You know, we I my wife spent some time as a census taker a long time ago.
Oh,
Um,
good.
and those forms are pretty structured for humans that speak English and spatially can understand what's on a form, but that's unstructured to all the mechanisms that are used to train a model. So, yeah,
Exactly, right? Think of free text. Some of those surveys say other. That's the worst thing for
sure.
for
Yeah,
researchers when you have other and fill in the blank, because humans we're not very efficient with our communication, right? We have a lot of words that mean the same thing,
right,
and we have a lot of words that sound the same that mean very different things.
right.
And this is where large language models or small language models do an incredible job at figuring out what those words really mean and putting it
Hmm.
into something that a machine can understand.
Sure.
Um, and so I really see in the next I see it happening right now, but I see it growing in the next 3 to 4 years. The emergence of small language models and agentic AI working hand in hand, where I don't need a big model. And these can run on edge devices on very low power. We're talking under 100-watt power type things instead of 100 kilowatts. Uh,
Hmm.
so we're talking magnitudes of power differences here, and I think
I'm
that's what we're going to see more and more of.
Yeah, I certainly see that vector emerging by utility and necessity, right?
Yes,
Um,
yeah.
so for whether it's a Census Bureau example or a financial services 10K 10Q example, you did make the comment that no one should be training their own models. How do you? So what do
Well, let me rephrase that
these?
a little bit.
Yeah,
Let the
very good.
big boys train the big models. Go for
Right.
it.
Okay. Yep.
Right. But if I am if I'm Intel, for example, I really shouldn't be training my own models. There's no reason to. The
Sure.
models are out there already that I can use. There's a lot of open source models. And people go, yeah, but I want it to be trained on my data. Well, there's
Hmm.
other techniques that we can use, whether it's context engineering or using RAGs, which are retrieval augmented generation. The whole
Hmm.
concept of these things is if I give this small language model some context, then I don't have to train it. I can
Right.
just augment my prompts with more data and it will give me responses according to the data that I give it. So w- people have invested millions of dollars into these training rigs that they don't necessarily need. The
Sure.
big boys, sure, they can continue to work on these models, but there's lots of open source models that are highly available that speak in multiple languages that are totally reliable enough to get this type of work done that we see people asking.
Let's also tease out your vision, what you see happening in the next 3 to 4 years of agents or digital coworkers, if you will, working with these smaller models. What will that look like for someone in government trying to figure all this out?
Well, we're actually not waiting 3 or 4 years. We're doing this in the US Census right now, and I call it collaborative work with an AI. And
Hmm.
we've actually created a really cool design pattern so that an AI and an information worker are working together, where we're augmenting the information worker with the AI. So, a term that a friend of mine, Doug Schmidt, coined was the augmented, AI augmented.
Sure.
That's where I see it working,
Right.
right? And I can't wait to get the T-shirt, right? AI augmented. Um, but what we're seeing is that these AIs working with a human together, we can actually create context such that the AI will learn from the worker by building these small little context databases that sit next to the AI that teach that give context to the AI on how to do the work. So
Hmm.
as I'm interacting with it, it's taking how I interact with data and forming these little tiny knowledge bases so that next time the AI, when it reads something, it has the interaction that I had before. So I don't want to call it learning because it's not traditional training of a model,
Sure.
but the end result is that the accuracy of the model increases as it works with the human. So I see us working hand in hand together, and just like people had to learn how to use word processing, people are going
Sure.
to learn to use AI more effectively. And I
Boy,
think
that's
we're
a
going to,
great analogy. Yep. Yep.
yeah, I think we're going to see like 10x improvement in productivity in the way that people work. I think it's going to be incredible time.
So are there specific use cases that you're seeing are really common in your federal engagement? Like what are some of the low-hanging fruit tasks that people can be taking advantage of?
Oh, low hanging fruit task is reading through lots of data.
Hmm.
This is where these large language models do a great job, right?
Sure.
Analysts at the U.S. Census Bureau, for example, they will read through 10Ks and 10Qs. They will read through spreadsheets of data that are coming in and curating it and mapping them, saying, "All right, this field maps to this element in a database," so that the data scientists can actually run the analytics on it. There's a lot of data tagging and curation that happens. And we've put in place using some of these small language models and some of the process and techniques that we built around it so that a human that's working with data and an AI that's working with them are building these, we call them atlases of maps on how to
Hmm.
map data from one thing to another. And these maps get built up over time as they interact with each other. So now when the data starts flowing through, my accuracy on the mapping becomes 99.9% instead of the 70% that I started off with. So this interaction on processing language, processing data, and mapping it to other data, I think is a prime target for this sort of stuff.
Do you see data engineering making a comeback? We 5, 6, 7 years ago, being a data scientist was the cool new thing before, OpenAI hit the scene, but there's still all this data hygiene, tagging, creating structured data that's like extremely critical. So how
And
do you
and
see
you
that
hit it
playing
on
in?
the nose, Scott. It used to take everyone knows this in the data ops pipeline. 80% data curation and cleaning, 20% analytics.
Right.
Everyone knows that,
Wow.
right?
Wow. I didn't know that, but now I
Yeah.
also know
Yeah.
that.
It took
So,
forever to get your data into the right forms in order to run really valuable analytics and gathering the data, knowing where it all was. That is where the main focus should be right now. And the people that are on the bleeding edge are working on that right now. They're saying, how can I get this data that's hard to work with
mhm.
tagged and automated so that I can get real value out of it quicker? So if we focus on that, that to me is where we should be focusing right now. That's where the value is. Um,
So as an aside, if there are young people who are trying to figure out what to pursue in university, or people looking to pick up other skills? How, or parents of said young people looking for things, how, where would they go? What would they study? How would they move along a career or acquire skills in this area?
So, you know what? I would tell anyone today, and I teach at Vanderbilt University. I teach computer science, and my students are in for a rude awakening. This Thursday, we kick off the semester.
Oh boy.
Um, Cloud computing is what I'm teaching, but I'm actually teaching them how to use generative AI to get their work done. So for
Sure.
anyone out there in it doesn't matter which field, if you're putting your head in the sand and saying, I'm not doing AI, you're not going to have a job in the future. You're just
Right.
not. Those that understand how to leverage these language models and generative AI to get valuable work done, right? And that value only comes from your interaction with it, not you just giving it one prompt and spitting out an essay at the end. It's how are you working with it to get your own voice put into the final product. That skill right there is
Hmm.
probably the most important skill that you can have. Now, if I were looking at the computer science realm right now and which area to focus on, absolutely in data management to me is going to be critical, because if I can't get valuable data into these data AI data pipelines, I can't produce value out of the back end. So
Right.
understanding data, understanding how to work that data into these small language models and into these agents that are starting to be built, that's going to be critical moving forward.
Yeah, I think listeners take note, right? I've had multiple conversation with parents who are trying to help their kids navigate what to study and where to go. And this seems like something that's going to be useful for quite some time in terms of the whole AI data pipeline.
Absolutely. And I go back to students need to learn to not fully trust what's coming out of an
Yeah.
AI.
Skepticism, like healthy skepticism.
Skepticism, yeah,
Yep.
and critical thought,
Yep.
interacting with the final product instead of
Hmm.
just, oh, I'm going to write one prompt and it's going to spit out a result. That's not valuable. The real
It's
value
enticing.
comes,
It's
yeah,
enticing because the output is generated with such confidence. Of course, I should just be able to, trust it and cut and paste. Um,
yeah.
and we've been burned. We've all been burned one
We've
one
all
way
been
or
burned.
another. Yeah.
That's happened to me as well. But the real value comes, and I'm hoping that universities catch on to this. I'm trying to push this forward across universities across the United States and the world. Is teach your students to inject their own selves into the final product,
Hmm.
instead of just trying to catch them cheating,
Right.
right? So it's a different mindset.
Yeah.
So to me, if you're a parent of kids, which I've got 10 kids, 3 in college this fall, um, I'm teaching them, guys, you've got to interact. It needs to be you that's showing
Right.
up on the other end, because ultimately you need to learn something. Getting a grade doesn't matter. It's, did you
Right.
learn something valuable?
Yep.
Because that's what's going to make you a valuable worker in the future.
That's some important things for every listener to think about. We could keep going on in that. I do want to take this back to the hardware aspect.
Sorry
And
about that, Scott.
no, no, it's a very productive. I'm not even going to call it a tangent, line of discussion. Um, but let's think about, okay, these smaller language models being able to run on more vanilla compute hardware, and impact that can have on data center infrastructure over the next few years. How do you see that playing out?
Well, this is where some of the good news comes in. A lot of people are in the mistake, have made the mistake that I can only run generative AI on GPUs. So I need to get in the queue, right? Because GPUs are in high demand,
Sure.
right? So I need to get in the queue. If I buy now, I might get it a year from now. I'm telling you, you don't have to do that. And you don't have to pay $40 an hour on Amazon for a GPU. You don't need to do any of that. You can actually run these smaller language models like Llama 3.2
Hmm.
or Gemma. There's a whole bunch of them out there, right?
Right.
Um, that you can run these on your Xeon processors that you have in your data center today. If you have spare cycles, or if you don't, go ahead and buy some because I work at Intel. I want, we need some revenue, right? But
Fair,
you
fair
can,
enough. Fair enough.
yeah, you can go out there and use your infrastructure that you already have to run these new types of models. And specifically, if you're looking at agentic AI, you're looking at agents that work with AI. Here's the dirty little secret no one's talking about. Agents don't run on GPUs. They run
Right.
on CPUs,
Yep.
and they're actually going to do most of the work for you. The large language model, the Gen AI, is just interpreting the language and putting it into actions that need to actually be done. That whole infrastructure you probably already have. And you've already learned how to optimize for those types of infrastructures, right? Where you're only you may have racks of machines that only have CPUs in them. And those are perfect for doing agentic and doing real work in the back office and real automation in the back office. And the power envelope is like 1/10 of a full rack of GPUs. So you
Well,
got your
if
power
you have
envelope down and your costs are way down as well.
if you have racks of, boxes with CPUs, that means you're like most every data center operator,
Yeah,
right?
yeah, absolutely.
Um, so how would people go about analyzing, do I really need to go for a GPU-based solution versus smaller language models on CPU? Is there anything you can point people to, or do you want people to call you to talk
They
about it?
could
What's
call me,
what's
but there's some white papers that are coming out
okay,
very soon. Research that we've done with lots of partners. There's several white papers coming out on the value of small language models running in CPUs. We've done a lot of work at U.S. Census Bureau in practical use. We're not using GPUs at all, and we're crunching through millions and millions of documents. No GPUs, all CPU based. Um, and and like I said, there's some white papers coming out that are showing performance and accuracy numbers running on these small language models that have been tuned for CPUs. I mean, there's lots of them out there. You can go to Hugging Face and find quite a bit of information.
right? Describe Hugging Face for people.
Oh,
Most
sorry.
probably have not used it. Yep.
Hugging Face is the repo where all the large language models live. There's a couple out there, but Hugging Face is the big one. So if you want, you can go to. It's a funny name, I know, but you know what? Technologists like funny names.
They
We
do.
do.
Yeah.
Um, so Hugging Face is a repository where you can download these large language models. You can run them on your laptops, on your data centers, on GPUs. It's really cool how they've put that all together.
I think at the time of recording here in August 2025, I just heard the other day that they crossed the 2 million model mark. Now, many are variations of similar base models, but still,
It's
in three
amazing.
years, over
Yeah.
2 million models. Yeah,
Well, and you do need to be somewhat careful.
sure.
Just like any free software you're going to download, there are several of those models that have viruses in them and things like that. So if you
Yep.
are downloading models from Hugging Face, go to a verified repository, someone that you know and trust, instead of Billy Joe Bob's Llama 3 or Darren's dark web LLM that's probably got a virus in it, more than likely. So just be
Dr.
careful when you're
Dr.
going out
Darren's
there.
dark web. That's
Yeah,
right.
Dr. Darren's dark web.
Well, there's so many places this conversation could go. You've covered a lot of ground. As we wind up, what does the next year or two look like? What do you think are important for people to be thinking critically about in the AI space? And where would you point people for more info to make themselves educated?
So first off, if you're sitting on the fence, get off the fence. That's the first thing I need. You've got to start doing things today. And if you're sitting on the fence because you're worried about which direction to take, I would say take any direction first off. Just learn about it, right? Learn everything you can about it. Start experimenting. Um, it is difficult to cut through all the hype because there's so much hype involved. I would say go listen to my show. I have a lot of people on that are practitioners of Gen AI, and
Sure.
that's embracing digital transformation. Um, but there's lots of this is the hard part. I can't point to one place and say this is where you're going to get the truth because there's so much fluff out there and so much misinformation still. So I would say you gotta weed through it all, look at several sources, and use something that we've all been given. The thing between your ears. Use your brain. Your gut will also tell you whether something isn't quite right or not.
The
And
actual intelligence, right?
the actual intelligence. Yeah, I like
Yeah.
that. AI, actual intelligence.
Please feel
But
free.
yeah,
No attribution required. Yep.
you do have to get some understanding. You do have to learn. So get out there and learn, um, and you'll discover a lot just by just exploring.
Well, you've provided a great set of starting points for many listeners. Just like you said, you have to caveat emptor, trust but verify, and assimilate from many sources. Part of what we're doing on this podcast is providing access to individuals just like yourself who are doing important things here in AI and the impact on data center infrastructure. So, Dr. Darren, thank you so much for being here today. We really appreciate your time. And thank you, listeners, for tuning in to the Caresoft Data Center Innovation Series. Stay tuned for more coming from us. Have a great day.
Thanks, Scott.